Welcome, everybody. Thanks for joining us here at the Vultr booth. I'm going to tell you a little bit about our story here at Clarifai and how we're orchestrating AI workloads across any infrastructure at any scale you can imagine. So we see, as we talk to a lot of customers, there's this big challenge, a big gap between starting with a prototype and actually getting that to production. And these are some of the kind of metrics around that. People are investing in AI. Clearly, you can see the success of NVIDIA here. And the big problem is that even though they've invested a big portion of their budget, it's not being utilized. 80% on average is not being utilized. So that's a huge waste. If you multiply those things out, that's really half your budget going to waste. We also see this problem of everybody cobbling together a bunch of tools. You might have, LLMs, you might have evaluation metrics, vector databases. All these things come together to solve a problem, but then you're left with something you've stitched together, you have to maintain, it becomes obsolete, and it becomes a nightmare for your IT team to control and provide governance over. And on average, about 8 different tools are being used by every different team within an organization. And overall, everything compounds to be slower than expected. 6 months delays in even getting access to GPUs. And then if you think about that AI sprawl problem of all these different tools, that's further delays on the software side. So this prototype to production is really, really a big problem. And that's how Clarifai comes in. We help bridge that gap, taking you easily from prototype all the way through not just day one of getting to production, but keeping your systems up 24/7 at any scale. And we've built Clarifai to be vendor agnostic. So we work across multiple different clouds, including Vultr, announcing today that we are supporting Vultr as a first-class cloud on our platform. Really excited by that. It's been awesome to work with Vultr, making that possible. And they got some great compute, so I'll show you a little bit about that in a minute. We support also multiple different chips, GPUs, TPUs, CPUs, so pick your favorite and it'll be supported within Clarifai. And then once you have your compute, we optimize it. So we fraction GPUs so that you can actually pack multiple workloads into the same GPU. So you're not having that 80% of waste. We auto-scale automatically. So we built custom autoscalers that scale to 0, very importantly. So if your workload's not getting any traffic, maybe it's a daytime, nighttime thing, maybe it's a sandbox, maybe you forgot about it, you don't want to be wasting money on that. On the other side, it auto-scales up to really infinity. As much compute as you can throw at it, it'll scale based on traffic. And then with these workloads running, regardless of on-premise, in the clouds, you get the governance and control, all your team support, role-based access control, all in one place. So it helps you accelerate all the way through to production. So the way this looks in terms of architecture, we split out a control plane, that's clarifai.com, and you can connect all your different compute planes. So that at the click of a button can be a Vultr compute cluster, it can be AWS, Google, and in your own VPCs, you can also connect those. So it doesn't have to be in Clarifai's VPCs. As long as it's running Kubernetes, you can connect it. And that includes on-premise data centers, if they're running Kubernetes. And then you can manage all of this different compute, regardless of where it lives, in one place and orchestrate workloads across all of that. And there's a lot of really exciting use cases. Maybe you have a fixed size on-premise data center, you use it all up, you need to fail over, you start ramping up machines on Vultr, you hit capacity there, you go to another cloud, you can manage all that seamlessly. For our most security conscious customers, we do a lot of work with the federal government, for example. We can deploy the control plane on-premise and connect multiple clusters that way as well. And with any of these tools about managing AI workloads, it's not going to be exciting unless your AI team's using it. And so we made that a first-class experience because our own team of AI engineers are actually using this to upload models on behalf of customers. And it looks a little something like this. The code snippet you see in the middle is how you define a function. And it can be any arbitrary Python code. You can have loading of large checkpoints, for example. You subclass the load model method. And then you can define prediction of a single request, single response, or generate, where it's a single request and streaming back responses like an LLM, or bidirectional streams. So maybe it's video frames coming in and you're detecting and tracking objects within those frames coming out. And so you get all the different flavors, and all of this is built really low latency streaming. On the right-hand side, you're seeing a little bit about the configuration. So you define your model, and then you configure it, saying things like you want a specific type of GPU over here, an A10G, a specific amount of memory you expect this model to consume, and then we use that information to orchestrate where it should run and how it can pack into that GPU alongside other workloads of different sizes. So if for example, you were on an H100, which has 80 gigs of memory, you could fit 4 replicas of this model or 4 other models of similar types. And then once you configure it, you can test it locally, make sure it works, and then in another one-line command, you can upload it to the cloud. And I'll show you what that looks like live. Then for this, I'll show you actually what it looks like to dive right in. You can configure the compute, and I'll do that right in our product. Hopefully the Wi-Fi is going to be good enough to do this. But what you get when you log into Clarifai.com is a brand new dashboard. This is all live. If you've ever signed up for Clarifai in the past, you wouldn't have seen this until today. So please sign up, take a look. And it drops you right into a whole set of models that we've curated. We maintain the state-of-the-art models in our platform, usually within hours of them being announced. So Gemma 3, for example, came out last week, and it was in here. And so we got those trending models, and within minutes of signing up, you can test them out in our playground and see if they solve your problem. Now, the playground is running on shared compute. That's compute that Clarifai manages. You never have to think about it. You pay per request, and it'll scale for you. Once you start getting serious about going into production, that's where you can one-click create different compute. So we have a few helpers here to get you compute on the basic side, advanced, and then I'll show you what it looks like to configure this even more. All the compute you've already created. In this account, I've created a few different clusters and different pools of nodes within them. You see that here. And then a quick start. If you're a developer, you can grab the code snippet, copy and paste it, and start making API calls that'll scale as much traffic as you throw at it. We got some doc links, and then we got all of your AI resources. So we have project management, we call apps, we have all your models in one place, your data sets, you can chain together models into workflows. So all that in one place right here on your homepage. Now, let me try a model like this. So if I go into the playground, I'm looking at Gwen 2.5. This is a visual, a VLM multimodal model, so I can upload images to it and say, what is this thing? And we'll see what it thinks. It should come back in a few seconds, and it's talking about what phylum this starfish is in. So it's very fun to play with these types of models. If I try that image again, maybe I ask it, how many things does this have on it? And we'll see what it thinks. It's a starfish. There we go. It figured out what a thing is, and it thought that was 5 arms. So very cool to play with these multimodal models. It can help answer questions in chat based on images. And as you can see, everything's very fast, low latency. And this is running on the shared node pool. Now, let me jump to an example. This is now Llama 3.2. This is running on a Vultr node pool. So this is running on an A16Z. Telling me. So immediately, we're starting to stream back results. So within a fraction of a second, you can build real-time chat experiences. We'll show you some benchmarks of this a little bit later. We think we're actually the fastest in the world at this point. So very excited by this new interface. And this is actually running in New York cluster in Vultr on an A16G or A16 GPU. Now let's take a look at what that looks like to actually provision some of that compute. So those are some of the off-the-shelf models, and I'll show you what it looks like to upload a model as well. But you can also create new clusters. So in the platform, at the click of a button, you can select your provider. I can go here, pick Vultr. I can pick a different region. And I've already created a cluster, so I'll show you what the next step it looks like. Coming soon, you'll be able to get that one-line install into your existing cluster as well. So that could be your VPC or on-premise. Now let's take a look at an existing cluster. So we got Vultr here. Within a cluster, I can create pools of nodes. So these are all of the same type, and I get to pick from a variety of different types that Vultr supports. So here's an A16Z, like I was just showing you. Here's an L40S. And we also have a lot of CPU nodes as well. So if you're just doing some compute-bound CPU workloads, you can pick the right size for you. And you can also configure the number of instances on the min and max side. So both these are very important. On the min side, the difference between 0 and 1 is actually really important. If it's 0, it'll actually scale down the whole pool of nodes to 0 if there's no workloads running in them, costing you 0. That's a good cost saving. The trade-off is that when you pull up a new node, it takes some time. With any of the cloud providers, that's true. So to prevent that, you can have a minimum of 1 or more, and that'll always keep a node hot and ready so you can schedule workloads to it. On the other side, you can set a max. So maybe this is a sandbox environment. You just want your research team to have 10 nodes to play with, but you don't want them to spend too much money. Set the max there. If it's production, you can leave that unlimited, and it'll scale to whatever you need. So that's how you can create a pool of nodes. Now let's take a look at some of the models, and I'll show you what it looks like to schedule across different nodes. So I'm jumping quickly through this. This is kind of the projects within a project in my organization. This is a Clarifai demos org. I can have projects like this that house my input data, data sets, models, and I've uploaded a few different models here. Before this, you can manage data labeling tasks at scale. And if I go in here, this is a model that just ran on a Vultr CPU node. And you can actually see, this is coming back from the model Python code. It's telling you that it ran over there. I can just as easily run that over on Google Cloud or AWS, or I can go to an on-premise data center. And so I just ran 4 different predict requests across 4 different complete clouds in the same way. I didn't have to rebuild my model, didn't have to send it to a different Docker registry, didn't have to think about scaling it up and down. After this demo, I don't have to think about turning off all the costs there. And this helps you do that on a line-by-line basis. So you can actually dynamically route traffic for your application, doing failover across clouds, etc. So we're really excited about this because it helps kind of solve that problem of GPU shortages, which everybody's seeing out there in the market. Some clouds have different types. I've never seen a cloud have an A16, which is awesome. Vultr has them. And it's a low-cost one for good workloads like we saw Llama 3 streaming back on. So let me show you what it looks like if you're a developer, that experience. So I'm going to jump right into a code, and here we go. So on the left-hand side, if you're following me over here, this is that model interface. So this is a very simple Python that will basically return back the string that's sent to it and nothing else. And we are about to launch in the next couple weeks an interface that looks like this. So this is a sneak peek of what it's going to look like. You can not just define those predict, generate, and stream like I talked about earlier, but you can literally define any function in Python like F or G, and you can take in any type and return any type. So this one's taking in a string, returning a string. This one's taking in a string and streaming back a string. So if you're familiar with Python, yield. And then this one's taking in a stream and yielding back a stream as well. So that's how I define my my model. Now I can do that Clarifai model upload, and it's going to then send it to our cloud, and it's going to build a container. And we've highly optimized this build process, distributed across multiple nodes, lots of caching. And so typically builds, even for big models, take about 10 seconds, like you just saw. Now, typo. Yeah. I'm going to make a prediction call, and I'll show you what the predictions look like. In the background, it's actually scaling up that model for the first time. So on the client side, this is the Python client. I have that model. This one's going to happen to go over to AWS. We can change that to Vultr just by changing those 2 lines. And then here, it's going to predict results back, calling F, calling G, and calling S. So as I in the background, it actually scaled up that, and here, it printed in the streaming function CCC. I can go ahead and edit that, and let's go re-upload a model. So I just made a code change. As an AI team, you've done this 1,000 times. It's a pain having to rebuild your models, and every time you change code, maybe you have a bug, you uploaded it, takes you like minutes or hours. We wanted to get past that process. We've done that for 10 years, and as a company of AI experts, and we wanted to make that experience much, much better. So there we go. That one will be running. And let me just go grab from my compute, I'll go grab the Vultr compute cluster ID. So I'll take that over here. Let's get rid of AWS, throw that in. And then I will grab this guy, the CPU node pool, and throw that in there. So here we go. That ran on AWS with DDD. Now I'll call it predict. This is going to schedule the same model up over on Vultr. I didn't have to do anything else. This will take, depending on if a node is ready, if it has the space, it could take a matter of seconds to a matter of minutes, depending on how big your model is as well. And we give you feedback that this model is deploying. It'll iterate through, keep retrying until it's hot and ready. And then subsequent requests will be very quick after that. And so we'll come back and, oh, I didn't even have to. There we go. So model's up. Now it's hot. It should come back, in real time. So we just showed 3 different ways of calling a Python class and ran it in Vultr right there. So great, simple development experience. On top of that, you give all these controls. So you'll see a lot of dashboarding when you scale up your usage and production, seeing how much your models are used, your compute is used, how much that compute is costing you. You also see this project management, but team management as well. So you can assign groups of people together and then assign the team to the different projects and control their permissions. So for example, you might have data labeling teams. You just want them to be able to create labels. You don't want to give any of the other fine-grained permissions like you see on the right here of creating clusters and incurring that cost. You leave that to your admin team as a good example. So all that is built right in. As you saw when we looked at some of those popular models like Gwen or Llama 3.2, it was very fast, instantaneous, low latency. We benchmarked ourselves against other people that focus on speed. They build their own kernels, and we're actually surpassing all the ones we've tested so far. So we're really excited to launch Compute Orchestration and especially launch it on Vultr here today. Also, the throughput's very high. So we've really optimized not just the models, but the whole end-to-end of the API that is between your model and your software, so that it is built for the best experience for you. Now, each of these different aspects of fractioning, spot instances, scaling to 0, they all compound because they're independent factors that save you money. So GPU fractioning may be 2 to 4x. You can pack in that many more models, drive up utilization. Spot instances are usually like 2 to 3x. Cheaper auto scaling, depending on your traffic, could even be 10x if you're not careful. And then batching requests are also supported. So you can send multiple requests. That drives up utilization as well. So all that drives significant cost savings. And that's not even taking into account all the time your team is going to save. Instead of building the tools to build AI, have your AI experts customize the AI for your business, and we'll take care of scaling it up. And so we really set ourselves apart on that flexibility, all the governance and control that drives security. By the way, that compute plane connection back to our control plane, we filed some patents around the security around it, because you don't have to even open up VPC peering or firewall ports in order to connect your clusters, even if they're on premise. So really proprietary stuff that drives security angle. We really intentionally build this to be vendor agnostic, run it anywhere, and get the most out of your compute. And then on top of that, stuff we didn't even talk about today, we have all these tools to actually create the workloads. So if you need help labeling data, one-click training models, orchestrating multiple models into workflows like retrieval augmented generation or agentic workflows, that's all in our platform as well. So next steps, come talk to us. There's a few of us here, Sajai and myself. And we're also giving away a good promotion here today. So if you sign up with this QR code, you can actually get 10,000 free credits to get started, start driving compute together on Vultr and Clarifai. So thank you all for listening. And Yeah, come join us.